Hello, how are you? Welcome back to our channel. Today we are going to discuss about part 3 from the electric charges and fields. Already in crash course 2022 I have completed that what is the Coulomb's law and applications in part 1, and part 2 I focused on intensity of electric field. Now we are going to discuss about our main concept in this part 3 is what is that, what is the electric flux, what is the gas, what are the gases laws, and we are going through the applications of the gases law. Then today I want to complete this part 3 also, and complete chapter we are finishing. This is the base of the all electric topics, so don't miss the electric charges and fields. Then come to our point today. First one we are going to discuss about the electric flux. What is the electric flux? The number of electric lines of force passing through the area and perpendicular to the area is called electric flux. We can show like this. Here we are giving some gap, means these are, suppose these 4 fingers you feel electric lines of force, these are passing perpendicular to the surface. Is called what? Electric flux. Electric flux is represented by phi. Suppose you consider a small area for this. This is the ds. And this is the intensity of electric field. Then how to write the expression for the electric flux? Electric flux phi equals to integral of E bar dot ds bar. Here it should be right E ds cos theta also. Theta is the angle between, most of the people we are confusing here only. Theta is the angle between intensity of electric field and normal to surface area. Normal to surface area. Normal to surface area. See, suppose normal to surface area, if E is the intensity of electric field, theta is normal to that surface area. Suppose this theta is, this normal is perpendicular to this E bar. Then what we are taking, don't consider the angle between E and ds, we must consider angle between the E and normal to the ds, that is the main thing here. Suppose if theta equals to 90 degrees, theta equals to 90 degrees. So what happens, E and this normal to the surface, both are perpendicular to each other, cos 90 is 0. So in this case electric flux equals to 0. That's why clearly I mentioned in this definition the number of electric lines of force passing through the area perpendicular to the surface. When it is perpendicular, so what is the angle? Angle theta equals to 0 degrees. We are getting cos 0 equals to 1. So this is about the electric flux. Then we are focusing on the linear charge density. Linear charge density. But there are 3 types of charge densities are. One is the linear charge density, another one is the surface charge density, then third one is the volume charge density. How the charge is distributed, they are divided into 3 cases. First one is the linear charge density. This is somewhat little bit you feel difficult comparing with the first 2 parts. So listen carefully. Charge distribution. First one is the linear charge density. Linear charge density, lambda equals to charge per unit length. If you are taking any wire, the charge is distributing uniformly. At the time, how to find out the charge density? You know the charge and you know the length. So we can find out the charge per unit length. This is called the linear charge density. Second one is the surface charge density. Surface charge density is represented by Q equals to charge per unit area. Here instead of area we can take S also. Sometimes we are taking S, sometimes we are taking A also. Then third one is volume charge density. Volume charge density, it is represented by eta. So charge per unit volume. From this you can charge, we can calculate lambda into L. Here charge Q equals to sigma into S. Here charge Q equals to eta into V. So this is about the charge density. Suppose you know the lambda, automatically you can find out the Q. If you don't know Q, you can find out. If you don't know the length also, we can able to find out. Then our next concept is Gauss's law. Gauss's law. What is the Gauss's law? The electric flux around any closed surface. Suppose you are taking any closed surface. This charge is how much? Q1. You are taking cross. This is the Q2. And this is the Q3. One more, that is the Q4. So here total charge is how much? Q equals to Q1 minus Q2 plus Q3 minus Q4. Why? It is cross mark is representing the current is charge is passing into the plane of the paper, and that is passing out of the plane of the paper. So opposite signs we are taking, that is the charge, total charge of that closed system. Suppose here we are taking Q5, here we are taking Q6 outside the surface. No need of considering. This Gauss law equals to 1 by epsilon naught times of the charge. You are having one of the short answer also. This is the formula. Any complicated conditions also we can solve, and we can find out the intensity of electric field also with the help of the Gauss's law. Then we can write it here, Q1 minus Q2 plus Q3 minus Q4. Like that, this is the Gauss's law. Now we focus on applications of Gauss's law. What are the applications of Gauss's law? Here just I am saying that formulas only. We are taking infinite long charged conductor, and you should consider a cylindrical Gaussian surface of length is L and R is the radius of this one. Here you consider a small area, that too the intensity is E, and this area we can take it, this length we can take it small l like that. So in this case E equals to lambda by 2 pi epsilon naught into R. R is the radius of this one. Instead of lambda, we should write it Q by L also. If you want to write, we can write it Q by L also. This is the first application. Then second one is, we are taking one plane sheet, two-dimensional thing. Suppose this is the positive charge. You consider a horizontal Gaussian surface. In this case, you remember that intensity formula is sigma by 2 epsilon naught. This one we are using in the case of parallel plate capacitor also. Two plates we are placing. At that time, what is that intensity? Sigma by 2 epsilon naught plus sigma by 2 epsilon naught. We are getting sigma by epsilon naught also. So this is our second application. Whenever they are giving, suppose what is the use of this one? Q equals to 2 coulomb per meter square. Coulomb per meter square. Then how to find out the intensity of this one? Is intensity equals to sigma by 2 epsilon naught. So 2 by 2 into epsilon naught value, you have to remember 8.85 into 10 to the power of minus 12. So after simplification, our answer is, you can express in terms of 1 by epsilon naught, or based on the objective, so we should give the answer for this. This is the use of this one. Not only this one, here suppose we know that lambda equals to like pi epsilon naught. Lambda equals to pi epsilon naught. R equals to 1 meter. Then how to find out the intensity? See, pi epsilon naught by 2 pi epsilon naught into 1. So this one cancel. So E equals to how much? 0.5 Newton per coulomb. Like that we can find out the intensity of long straight current carrying conductor charge distributor, and this is in the case of plane sheet. What is the electric flux and what is the intensity and what is the intensity in this case. And third one also it's there. In that we have to go through the one sphere is there, conducting sphere. Outside that what is the intensity on the charged conductor, on the charged sphere, what is that intensity on the surface and inside. Look here, we are taking one spherical body. Here the charge is distributing like this. Suppose we want to find out the intensity at point P. From here to here you should take the distance is R and the radius is R. You consider a small surface and intensity is acting like this. So in this case, phi E equals to, we should write it 1 by 4 pi epsilon naught Q by R square. Same thing, intensity, sorry, not electric flux, intensity E equals to 1 by 4 pi epsilon naught Q by R square, general formula. But here we should explain in terms of capital R and small r, what is the radius of the sphere R? So in this case, sigma equals to, you know that, q by 4 pi r square. From this q equals to sigma into 4 pi r square. When we are taking in this E equals to 1 by 4 pi epsilon naught, instead of q, sigma 4 pi r square by small r square. Here 4 pi cancel. So we should express sigma by epsilon naught into r square by r square. It depends on the situation. If the r is at 2 meters, small r is radius of that one is 1 meter. Sigma value, you know the charge, you can find out that one. Epsilon naught value, we know that. So we can find out the intensity at any point outside the sphere. Suppose we want same third case, you look here. We can take the distance is here small r equals to r, and intensity is acting because it is positive charge acting away from this one. In this case, what is the intensity formula? E equals to 1 by 4 pi epsilon naught q by small r square only we are taking. Like the third case, this is the sphere, charge is distributing, but inside that always you remember that there is no charge in, so intensity is equals to 0. Like that we can find out the intensity of long straight distribution of the charged conductor, and in the case of plane sheet and in the case of sphere we can find out. For Gauss's law, this part is very important. You must by heart these formulas and you should remember, that is your wish. So it is an important, all important formulas are there in this part. Look here. First one, if charge equals to 0, then what is electric flux? Electric flux equals to 0. Two cases. If enclosed surface is there but charge equals to 0, so immediately you can say that electric flux equals to 0, because the formula is 1 by epsilon naught times of the charge. If there is no charge, charge is 0 means there is no meaning for electric flux is also 0. And at the open surfaces also there is no electric flux. It is only applicable for closed surfaces. So in the first condition, if q equals to 0, and for open surfaces always you remember that electric flux equals to 0. Then come to second point. Look here, it is like a sphere shape and cylindrical shape, one cubical shape we are taking. Whatever that enclosed charge is how much? In all these three cases charge equals to q. So electric flux is also same, 1 by epsilon naught times of the charge. We are doing one problem based on this. Look here, if q equals to 8.85 coulombs, then how to find out the electric flux? 1 by epsilon naught value also 8.85 into 10 to the power of minus 12. Charge is 8.85. So after that our answer is 10 to the power of 12. So like that we should calculate the electric flux. Whatever the shape, but the enclosed charge is q. That's why here same formula we are getting all these three cases. Then come to next one. Look here, it is the hemisphere. In hemisphere, first condition, look here, this is representing the electric field, and normal to this intensity, what is the angle? Angle equals to 90 degrees. When angle is 90 degrees, there is no electric flux, because cos 90 equals to 0. In first case, electric flux equals to 0, because here theta is 90 degrees. Then second case, look here, this is anti-parallel to this one. Phi equals to theta equals to 180 degrees. So E into this area of this one is the pi r square minus E pi r square. When we are taking magnitude, E into pi r square. So I think you all can understand these two. Here theta is 90 degrees. So there is no electric flux. Here theta is 180 degrees. Cos 180 is minus. That's why we are getting the negative flux. Then come to third one. See, if the intensity is like that, we can take it half of the hemisphere. That's why here electric flux equals to q by 2 epsilon naught. Then come to this one. These are also very important. If we are taking one cube, we are placing the charge at center of this one. In this case, what is electric flux? Phi E equals to q by epsilon naught. But come to second case, flux linked with each phase. We should consider each only one phase electric flux. 1 by 6 times of that q by epsilon naught. 6 faces are there, but we want only 1, means 1 by 6 we are taking. Then next case, q is at the center of the face. So how many center of that one, means we are splitting this one, we are getting half of that electric flux q by 2 epsilon naught. Then come to third one, if the point charge is at the corner, how many corners are there? 8 corners. We want to find out only one corner, means we can go through the phi equals to q by 8 epsilon naught. So this is about the Gauss's law electric flux. First we remember that the number of electric lines of force passing through the area and perpendicular to the area is called the electric flux. The formula is phi equals to, we are taking E bar dot ds bar. Here when you remove the dot, we should consider compulsory cos theta. That too, here most of the people are confusing. Theta is generally we are thinking intensity and area. No, here the theta is angle between intensity and normal to the surface. Normal to the surface. Suppose the intensity is parallel to the area, but the angle is how much? Theta equals to 90 degrees. Here we are saying that only. Intensity and area both are parallel, means angle is 90 degrees. Normal is making 90 degrees. In that case, there is no electric flux. If the intensity is perpendicular to the area, but normal and intensity are parallel to each other, so we are getting the maximum electric flux. What is electric flux? The number of electric lines of force passing through the area and perpendicular to the area is called the electric flux. Then we discussed about charge densities. There are 3 types of charge densities. When we are taking single dimension, uniform long infinite charged conductor, at that time how we are distributing that charge per unit length. If you are taking 2-dimensional, we should consider the area, charge per unit area. In terms of like cubical body, charge per unit volume. Like that we can distribute the charge, and we should analyze 3 dimensions. First one is the linear charge density, second one is the surface charge density, and third one is the volume charge density. Then it is coming Gauss's law. Statement, I think you are perfect in that Gauss's law is, formula is electric flux only it is giving. It is equals to 1 by epsilon naught times of the charge. That is in the case of uniform long charged conductor. What is the intensity? For plane sheet like board, what is the charge density? For sphere, what is the charge density? And here sphere also 3 cases we got it. Outside and on the sphere and inside the sphere, what is the intensity? In third case it is 0, and 2 cases already I have given explanation. Then we are going to discuss about electric flux in all these special cases. So try to understand these formulas and make that practice that problem. So total 3 parts are there in electric charges and fields. First thing, we focused on the Coulomb's law, main part. Then second thing is the intensity of electric field and electric dipole. This is the third one. We focused on electric flux and Gauss's law. And one more thing, many people are confusing while referring these videos and this one. Direct after subscribing only you can get the playlist. In that playlist you can go through the crash course. Then day wise, day 1 units and measurements are there. Day 2 that I have given waves chapter. Then ray optics I have completed. So total I have completed now units and measurements. Then waves I have completed. Motion in a straight line completed. Ray optics is completed. Then electric charges and fields also completed. So successfully we have completed 5 chapters. So follow that videos and revise. Crash means we can't explain in depth of all these topics, just revision of all this. And whatever you practiced already previous, you should once you look that one and practice, and minimum 3 hours you have to allot the time for physics subject, then only you can reach your goal. Thank you everyone. Please subscribe my channel, and in this moment share my videos and share the knowledge. It is benefit to all intermediate students. Thank you everyone.